Good morning and welcome back. And we'll see the second lecture regarding solution of difference equations. And already we have seen one way of solving the difference equation, that was simply by finding complementary function and particular solution and adding those two things, we'll get the final solution. So we have seen in detail how to find complementary function. So complementary function may have n number of constants, will have n number of constants starting from alpha 1 to alpha n. And then we have seen what is particular solution yp of n, and yp of n was in the same form as that of an input. Only that will not be in the form when there is when we have seen that is when the input is same as any of the terms of the complementary function. So we have seen one example, and last time also I have given a homework. I'll be giving the answer for that homework also along with the materials that I'll be sending today. So complementary function, so particular solution was in the same form of the input. Then we applied then we evaluated the constant term attached with the particular solution after substituting that particular solution in the difference equations given. And then we evaluated the value of k. We found what is the particular solution, and then we added the complementary function with the particular solution. And then we found the n number of coefficients or n number of coefficients of the complementary function from the initial conditions. I repeat, that is, we had the complementary function with n number of coefficients, that is right from alpha 1 to alpha 2. We found what is yp of n, that is something k into something which is in the same form of input. And after that we added the particular solution with the complementary function, and then we evaluated, and then only we have evaluated the coefficients of the complementary functions from the initial conditions. So after finding the coefficients right from alpha 1 to alpha n, we'll get the total solution. So that was a method we have seen in the last class. Today we'll see another method where we'll apply the principle of superposition. So what is superposition? Superposition means we may have several inputs, so we'll find the output or the response due to each input. So we take each input one at a time, so or each source at one at a time. So in a circuit, if we have a current source and a voltage source, and we have to find what is the current through a particular element due to both these sources, we'll see what is the current through that resistor when one source is there. That is, if we have the voltage source alone, what is the current through that resistance? That at that time we have to kill the current source. Then we take the current source alone. At that time we'll be killing the voltage source, and we'll be finding what is the current through that resistor alone. And then we add up those two currents, and we'll get the final total current that will be passing through that resistor. That is one at a time. That is what is called the superposition principle. So the same thing we'll be applying here also. That is, we will be having two inputs. So naturally a question will arise: what are the two inputs to a system? You are actually seeing explicitly, you are seeing only one input, the actual input, that is x of n. So what is the other input? So x of n is called the external input or the forcing function. Okay, that is the function which is evident, that is the input that is explicitly found, or you're seeing that. Okay, but what is the second input? What is the other input? So the second input is nothing but that is implicitly there, that is, they are the initial conditions. I told in the beginning itself that, so if you are solving an equation for any values of n greater than or equal to n naught can be 0 or any other value, you have to know the initial conditions prior to n naught. You have to know the initial conditions prior to n naught. So if we have to determine or solve y of n at any values of n greater than or equal to n naught, prior knowledge of initial conditions before n naught is required. only then you can solve that. So initial conditions are very important. Initial conditions can be present or it can be absent. So knowledge of that is required. So initial conditions are the second input. So first you apply the initial conditions alone, then you find the response. That is called the natural response. That is, so natural response or zero input response, that is y of y z I of n. What is z I? Zero input. That is, when we consider the initial conditions alone, the input is taken as zero. That is why zero input. So the response or the due to the initial conditions is also called as a zero input response or the natural response. So when you apply the initial when you take into consideration the initial conditions, the response is called zero input response or natural response. Okay, now that is the first case. So we have found that, that is what is the response of the system due to the initial conditions alone, that is the zero input response or the natural response. Now in the second case, we have to consider only the external input, the response due to the external input, and that is called the forced response. Forced response, or they are also called as zero state response. Zero state means zero initial conditions. That is, we are considering only the external input or the forcing function, and we are finding the response only due to that. So in that conditions, we are taking the initial conditions as zero. So earlier case, when we consider the initial conditions, we are considering the input as zero. Only then we find the response. So here when we find the forced response, that is due to the external input, we'll be considering the initial conditions as zero. So such a response is called forced response or zero state response. So you have two responses. One is due to the initial conditions alone, that is called the natural response or zero input response. Then you have the forced response, and that is only due to the actual input x of n. So that is called the zero state response. So those two responses you are adding, and you'll get the final result or the total solution or the total response. Okay, so this is the method we'll be following. That I'll be showing that using two examples. Only one example is required because all other methods are similar, and one have to make a note that zero state response is not the complementary function, and zero input response is not the particular solution. It is entirely different. Okay, but the end result will be the same as the previous method. Okay, so we'll see the first problem, where we have a problem. We have to find the natural response. So when you have to find the natural response, there is no input, and the only input is the initial conditions. So here you can see the initial conditions are given as y of -1 equal to y of -2 is equal to 1. So you have to find the solution for n from n is equal to, for any value of n greater than or equal to 0. That is why prior knowledge of n values, initial conditions before n, that is at n is equal to -1 and n is equal to -2 are given. Why two initial values, initial conditions are given? Because the order of the system is 2. When order of the system is 2, two initial conditions are required. When order of system is 1, one initial condition is required. So initial conditions, number of initial conditions depend upon the order of the system. Okay, so I have made a note also, natural responses only due to the initial conditions. So you write the question as such. Then, okay, so I told that for finding natural response, you need not consider the input or the actual input, the forcing function or the external input should be taken as 0. So the input is in the right hand side, you just equate that to 0, or you'll get that y of n plus 2, y of n minus 1 plus y of n minus 2 is equal to 0. Take that as equation number 1. The rest of the procedure is almost same. That is, this equation number 1 is called a homogeneous equation. Why it is called the homogeneous equation? Because right hand, the complete thing is equated to 0. Such a equation is called a homogeneous function or homogeneous equation. Then that is why it is taken as yh of n, and we try a solution, that is lambda raised to n. That procedure is known to you. Then you'll get the characteristic equation as lambda square plus 2 lambda plus 1 equal to 0. That is, it is equal to lambda plus 1 the whole square is equal to 0. From that you will get two roots, that is lambda is equal to -1 comma -1. That is, -1 is being repeated. And you know what is the procedure for having that is we have seen in the earlier video, that is depending upon the nature of roots. So roots can be distinct or roots can be repeated. So just go through that portion. I've given the material also, we'll be applying that. So here we have one repeated root, that is -1 is repeating twice. So in that case we'll write the homogeneous solution. Remember, this is not, even though it appears to be in the form of complementary solution, it is not complementary solution. The thing is entirely different, but it seems like a complementary function. Okay, so we'll take that form, that is alpha 1 into -1, that is -1 the whole raised to n, that is the -1 is a repeated root, that will be coming outside the bracket. Inside the bracket we'll be having alpha 1 plus n into alpha 2. We open those things and we'll get alpha 1 -1 raised to n plus alpha 2 n into -1 raised to n. So that is taken as equation number 2. So you will understand everything if you have gone through my last video or the materials that I have circulated. Okay, then from 2, this is the method you have to follow. From 2, that is 2 we have written, that is yh of n. You substitute n is equal to 0. So when you substitute n is equal to 0, y of 0 will be equal to alpha 1. Similarly, we have to find what is just substitute y of n is equal to 1 in 2. You'll get y of 1 is equal to minus alpha 1 minus alpha 2. Okay, then you take the difference homogeneous. Okay, that is, you have taken the homogeneous function, that is equation number, homogeneous equation, that is 1, and that is you can determine alpha 1 and alpha 2 if you know y of 0 and y of 1. So in earlier method, that is coefficients of complementary functions were determined only after adding that with the particular solution. So add the complementary solution with the particular solution, complementary function with the particular solution, and then you apply the initial conditions to find alpha 1, alpha 2, like that. Okay, here it is totally different. That is why I told that this is not, even though it appears to be in the form of complementary function, the procedure of determination of alpha 1 and alpha 2 is entirely different. That method I am showing here, that is, you have to find what is y of 0 and y of 1. That has to be determined from the homogeneous equation. Why it is homogeneous equation? Because here the actual input is taken as 0. That is, you have to determine alpha 1 and alpha 2 from the initial conditions. Okay, so there alpha 1 and alpha 2 were determined after adding the complementary function with the particular solution. Here there is no particular solution because input is absent. Okay, so that thing, the alpha 1 and alpha 2 is taken, is determined from the initial conditions. There also it was determined from the initial conditions, but only after adding that with the particular solution. So after adding the complementary solution, I am repeating again because this is a little bit confusing. So complementary function there in the earlier method was added with the particular solution, and then we determined the constants or the coefficients alpha 1 to alpha n from the initial conditions. Here, as the input is absent, there is nothing like a particular solution, and we will be finding the constants or the coefficients alpha 1 and alpha 2 from the initial conditions. So we have from a 1, you just substitute n is equal to 0, we'll get y of 0 plus 2, y of minus 1 plus y of minus 2 is equal to 0. In that you can see that initial conditions y of minus 1 and y of minus 2 is equal to 1. So you substitute that and we'll be getting y of 0 as minus 3. Likewise, from again 1, you substitute n is equal to 1, you'll get it as y of 1 plus 2 into y of 0 plus y of minus 1 is equal to 0. Y of 0 is already known, y of minus 1 is already known. Substitute and get the value of y of 1 as 5. Okay, so you got y of 0 and y of 1. You substitute in substitute in the values of y of 0 is equal to alpha 1 and y of 1 is equal to minus alpha 1 minus alpha 2. From there you'll get the value of alpha 1 as minus 3 and alpha 2 as minus 2. Okay, and then you substitute those values and you'll get the homogeneous function, which is the solution, that is, which is the natural response. Okay, so that is the answer to the first question, and we'll see the second question quickly. Second question is actually the forced response, the same question, but initial conditions are taken as 0 and there is only the external input, that is x of n and plus x of n minus 1 is there, where x of n is given as half raised to n u of n. So it is evident that n naught here it is 0. You have to find the solution for n values greater than or equal to 0. Okay, so here initial conditions are absent and you are considering only the response due to the actual input. Okay, so here again the homogeneous function remained the same, because first for finding, even for finding the complementary function, we have tried a solution and equated everything to 0, and so that we will get uh, the homogeneous function, because input was taken as 0 for finding complementary function also. Okay, so here also the homogeneous function will remain the same. We'll take from the previous question, that is alpha 1 into minus 1 the whole raised to n plus alpha 2 into n minus 1 raised to n. So that remains the same. Even for complementary function, that was the same, because the differential equation was taken and right hand side was equated to 0. Then we tried a solution lambda raised to n, and we got the characteristic equation. We solved the characteristic equation and we found if that is order, if the characteristic equation is of the order of n, then we had n number of roots, alpha 1, alpha 2 up to alpha lambda n, lambda 1, lambda 2 up to lambda n. Okay, and then we wrote the complementary function, which had its own form, which depended upon the nature of roots. So here we can see that it is repeated roots. So that is again the homogeneous function yh of n, which we have determined in the last question. Then here the difference is that we have the actual input, which is half raised to n u of n. So we know what is, so here you can see that the input is not in any way related or same as any terms of the homogeneous function. Okay, so we can follow the same method, that is how a particular solution will be in the same form as that of the input. So input is half raised to n u of n. So you'll take the particular solution as a constant k multiplied by half raised to n. Okay, so that is the same form, another constant multiplied by the same input. Okay, then you have to substitute that solution, that is the particular solution, in the actual difference equation. Okay, so the first term is y of n. Instead of y of n, you can have k half raised to n. You just omit u of n, because it is understood that we are finding the solution for values n greater than or equal to 0. And the next term is 2 multiplied by y of n minus 1. So instead of n, you can substitute n minus 1, that is it becomes 2k half raised to n minus 1. Likewise, the third term, that is k into half n minus 2, then equal to x of n. X of n is half raised to n, and the second term is x of n minus 1, that is half raised to n minus 1. And you just try n is equal to 2 in that previous equation. If you do that, you will get k into half square plus 2k half plus k equal to 1 by 4 plus 1 by 2. Okay, and from there you can determine that is k is equal to minus 1 by 3. So what is a particular solution? You just substitute the value for k. So yp of n is nothing but minus 1 by 3 half raised to n. Sorry, it's not minus 1 by 3, it's simply 1 by 3. That is 1 by 3 half raised to n u of n. So the forcing function is nothing but the sum of homogeneous solution, a homogeneous function plus the particular solution yp of n. So you know what is homogeneous solution, that is alpha 1 minus 1 raised to n plus alpha 2 n minus 1 raised to n plus just what is the particular solution, that is 1 by 3 half raised to n u of n. Okay, so this much is similar to the first method that we have learned. So there in the first method, you determine alpha and alpha 2 from the initial conditions. Here initial conditions are absent, so you have to determine alpha 1 and alpha 2 from the actual input, considering initial conditions as 0. That is very important. So here alpha 1 and alpha 2 are found out from 0 initial conditions. There alpha 1 and alpha 2 was the same equation was there, but there alpha 1 and alpha 2 were found that is from the initial conditions. That is you add the complementary function with a particular solution, and then you found alpha 1 and alpha 2 from the initial condition. Here also you add this similar homogeneous function, which is similar to complementary function, with the particular solution. Then the homogeneous function is almost that is equal to the complementary function, but that is added with a particular solution. The only difference is that alpha 1 and alpha 2 are determined from 0 initial conditions, which was not the case in the first method. There it was determined from the initial condition. It is found from 0 initial conditions. I am yelling because this can create confusion, that is why. Okay, see. So again, the normal, the first from the that is from the problem number one. We have followed a method, the same method. That is from three. You just substitute n is equal to 0 and n is equal to 1. You get the two equations in alpha 1 and alpha 2. Then again consider the difference equation and simply consider what is n is equal to 0. You'll get y of 0 plus 2 into y of minus 1 plus y of minus 2, that is equal to x of 0 plus x of minus 1. But y of minus 1 equal to minus, they are initial conditions, so they are taken as 0. Why? Because we are determining alpha 1 and alpha 2 from 0 initial conditions. So y of 0 is equal to x of 0 is nothing but half raised to 0, that is 1. Then x of minus 1, because as the input starts from n is equal to 0 and input extends from n is equal to 0 to plus infinity, there is no value below for or n less than 0. So x of minus 1 is 0. So y of 0 is equal to 1. Then in the same homogeneous same difference equation, you just substitute n is equal to 1. You'll get it as y of 1 plus 2, y of 0 plus y of minus 1 is equal to x of 1 plus x of 0. So y of 1 plus 2 into y of 0 is taken as 1. We have found that. So 2 plus y of minus 1 is 0, equal to x of 1, that is half raised to 1 is half, plus x of 0, that is 1. So from that, y of 1 is minus 1 by 2. So knowing the values of y of 0 and y of 1, you can find alpha 1 and alpha 2, which you will get it as 2 by 3 and 0. So if the forcing function is nothing but so as alpha 2 is 0, the second term of the homogeneous solution will be 0. So the forcing function will be 2 by 3 minus 1 raised to n plus the particular solution, that is 1 by 3 half raised to n. So we have, for the same question, we have found the natural response as well as forced response. So what will be the total response? That is, you simply add the natural response with the forcing function. Okay, you'll get the total response. So that is the second method of superposition principle. And then the third question, this is a special case. Suppose you'll be given with a difference equation and you will be asked to find the impulse response. So whenever you consider impulse response, initial conditions have to be taken as 0. I have already pointed out in an earlier method, because impulse response, if you find the z transform, then you can see that it is a transfer function. Transfer function is defined under 0 initial conditions. So whenever you are asked to find the impulse response, first and foremost thing that should come to your mind is that in the initial conditions to be, it should be taken as 0. Okay. Then the second point, which I will not be explaining now, that is the particular solution should be taken as 0. So for finding impulse response, two things you have to remember: the initial conditions are taken as 0 and the particular solution is also taken as 0. And then the input x of n is equal to nothing but delta of n. That is what is called, the input should be the impulse, then only you'll get the impulse response. Okay, so three things: the initial condition is equal to 0, particular solution is equal to 0, and x of n is taken as delta of n, that is the actual impulse. Keeping that in mind, you just see the method. You can see that it is similar to the method we have followed in the past two problems. You can just see that. Okay, so that is the third problem. So this is all about the solution of difference equations. Two methods. I have shown two methods. Certain problems or typical problems were also given. You follow that, try to do it your own. Okay, and impulse response is also very important. There we are considering three things: 0 initial conditions, particular solution is equal to 0, and the input x of n is nothing but delta of n. Okay, so I'll be circulating this material after this video. So thank you.